I characterize it in one of my favorite terms, which is, as it relates to data, is context.
Yes.
You can't train these models on irrelevant or nicked up or flawed data.
We had one recently that they, good data and all that. And then we're running and we're looking at physics and we're like, the machine that you think is sitting there is not sitting there. And they go back and dig through their paperwork. And sure enough, 6 years ago, somebody completely re-wheeled that compressor. And they're like, okay, well, now it makes sense, right? But there's a lot of power in understanding, in pulling it together in this way at one level. What Jimmy's pulled up on the screen is kind of the next step of this, right? And that's deviations. And this is a list of deviations. And my comment earlier about how you use physics and what you do with it, this is a list of deviations. And again, I'm not going to go through all the details, but you look at things like, hey, what's your deviation for power between the driver power and the equipment power based on all the gas property calculations? What's your deviation to power based on if the head was right, but the flow was wrong? What's the deviation if the flow was right, but the head was wrong, right? Those things allow you to start understanding, is this a temperature element problem? Is this a flow meter element problem? Which in my experience, the first thing you always need to suspect is a flow meter, right? But as you go through these,
and why is that, as a non-maintenance and reliability guy?
Yeah, flow meters just are one, gas composition changes impact them a lot.
Okay.
Two, especially in services that could have liquid dropout, they can have in one of the legs of the flow meter side on the DP element, they can have liquid dropout, and that'll shift them dramatically. So you can have, say, condensation that happens on a cold night, and you just build up on the high pressure side of that transmitter, you build up liquid, and that just shifts it way off, right? So you can have a lot of things that happen with flow meters, and they just seem to be more sensitive than, say, a pressure transmitter or a temperature transmitter that's sitting there, and primarily from things like condensation and from changes in gas composition, because it does impact the value that you get back. A lot of people output, say, standard cubic feet per day from a flow meter, which means that composition went into that as opposed to a raw flow element DP. Again, what's your deviation on discharge temperature? What's your deviation on all these? That helps when you take all these deviations, and these deviations now are transferable, right? These are on a percentage basis compared to what that machine's performance should have been. And those are much more transferable than any of the raw signals that went into them when you talk about, hey, this centrifugal compressor versus this one, or this recip compressor versus this one. So whether it's the same site or it's at another site, a different machine, these deviations are highly transferable versus raw, hey, the discharge pressure went down. Well, what's that mean, right? Well, the suction pressure went down too. That makes sense. There's, all of that stuff is intertwined here.